Alright guys, this is section 74. This could be a little bit confusing. The hardest part for this is not so much the algebra that comes with it. We're going to do a lot of that in the calculator, particularly the integrating. However, the picture of this is what makes it harder, right? So the cross-section other than circles. Alright, so it says let the base of a solid in the first quadrant plane region bounded by this function right here. That would be the y is equal to 1 minus x squared over 4 function. The x-axis, which is this, and the y-axis. All right, so that bounded region, just like the last section, would be located right here in this first quadrant. Okay, so that's what we're looking at. So suppose the cross sections are perpendicular to the x-axis and they're squares, and they want us to find the volume of the solid. All right, so for me, the hardest part was to try to figure out what this is supposed to look like. So picture a square, if you will. If this is you're looking at the top of the square, so the square is actually sitting like towards you, up and down. All right, so that's a square, and that's really the part that I had a lot of trouble with. So I found this picture on the internet. Obviously, this is not the same function, but you can sort of see, for example, these are squares, right? So that's basically what we're doing. We have a bunch of squares right here that are back to back to back. Okay, and if you put all those squares together, you would get the you would get the volume of the shape. Okay, so again, what we have here is a square right here, but we would have a bunch of squares backed, sitting right by each other. And as you do, you create this three-dimensional figure that you can see here, and there's a volume to that. Okay, so the first step to do this, all right, if you sort of understand that, and if you don't, make sure and ask me. Here are the steps to do this, all right, for all of this section. So steps. You need to find the correct area, meaning the area, in this case, the area of the square, right? So we're going to find the correct area formula, that is. All right, step number 2 would be find the variables needed for the formula, for the area formula. And then finally number 3, right, number 3 would be just to take the volume, all right? The volume, this is volume of the cross section, would be equal to the integral of the area. All right, so remember, just like in calculus that we talked about, the fundamental theorem in calculus, right? If I'm trying to get if I was just looking for the area here, I can get a more and more accurate area the thinner I make this delta x. Okay, so the thinner I make that, I can get closer to the actual area of this. And if I make the width very small, nothing, a line, then I can get the exact area under the curve. Well, that's the same idea here, except for now we're talking about area and volume. So if I have this square, remember, that's facing towards me, the thinner I make the thickness of the square, the smaller I make that, the more accurate I'm going to get to the volume of this shape. Okay, so for this one, number 1, the area of the square, as you hopefully already know, would be equal to side times side, which would be side square. Okay. Now, in this case, as you look at it, right, let's just concentrate on finding the area of this square. That's, remember, it's pointing up, right? I wish I could find a better way to sort of tell you that that's a square right there. But that's the best I can do. So to do that, remember that this length right here would be equal to basically the top curve minus the bottom curve. Alright, so on this one, the top curve would be 1 minus x squared over 4, and the bottom curve would be 0, because this line right here, remember, this line is y is equal to 0, which is the x-axis. Alright, so therefore my side is just equal to 1 minus x squared over 4, and that's it. Alright, so all I have to do now is, this is the side. Alright, so I'm going to integrate now. So this is step number 3. to find the volume of the cross, using the cross sections, I'm going to go between 0 and 2. And I'm going to put the area formula, which is this one, but instead of writing S, I'm going to write 1 minus x squared over 4, which, if you remember, this right here is the side. Okay, and I'm going to integrate that. This is square, of course. Remember, this is S squared dx. And if I integrate that, I'm going to get the volume of the cross-sectional shape. Alright, so this right here, again, this is cross-section. Right, and honestly, this part you can do in the calculator. So please do that on the calculator. The volume of the cross-section would be 1.067. Okay, so that'll be it for that. Alright, let's take a look at number 2. So again, if you don't understand this, make sure and pause to listen to it again. If not, ask me questions. Alright, so example number 2. So let me move this here. So we got example number 2. Now this one, notice that I already drew this ahead of time. Alright, the base of the solid is the region between one arch of the y equals sine x and the x-axis. Alright, so what we're looking for, we're looking at this area right here. And it says each cross-section perpendicular to the x-axis is an equilateral triangle sitting on its base. Alright, so this would be the thickness of the triangle. And if you remember, the triangle technically would be like, it would be like that, sort of. I don't know if you can tell what's going on here. And one more time, I'll show you that picture. It would look, even though it's not the same shape, it would look something like, actually it would look more like this one right here. Alright, notice that you have triangles right here. So that's what that would look like, okay? Okay. So that would be like the triangles would be coming towards you, like the point of the triangle would be going towards the camera. Okay, so if you understand that, and that's the hardest part, then the next part's easy. Alright, the first thing we have to figure out is the area of a triangle, and hopefully you know this, is equal to 1/2 base times height, right? So the problem is that this right here, I'm going to call this equilateral triangle that has sides S, S, and S. Okay, so this has sides S, S, and S. So what we're going to do is we're going to try to find out, we're going to try to replace this B and H with stuff in terms of S. So the first thing we're going to do here is we're going to say that if this is the height right here, if this is the height, alright, what we're going to do is to find the height, we're going to split this up. Remember, if you split this up, you would have a 90-degree triangle right here. I'm going to redraw that one. And this does not look like an equilateral triangle, but you get the idea. This would be 1/2 S. Remember, that would be half of this base right here. That's half. This would be S, and this would be height. All right. So to figure out height in terms of S, I'm just going to use the Pythagorean theorem. So I have 1/2 S squared plus H squared is equal to S squared. Right, that's going to be 1/4 S squared plus H squared is equal to S squared. Now if I subtract 1/4 S squared from each side, I would get H squared is equal to 3/4 S squared. Alright, and if I take the square root of each side, I would get square root of 3 over 2 S. Okay, so again, I'm going to replace all that stuff. Alright, I'm going to replace the B and the H that you see there. So let me put it up here again so you can see it. I'm going to replace that. So what I'm going to have instead, okay, what I'm going to have instead of this formula, I'm going to have 1/2. The base, remember we're going back to this one, the base would be S. The height would be what I just found here, which is the square root of 3 over 2S. Alright, so that's what I have for the area of the triangle. And that's going to give me the square root of 3 S squared over 4. So that's what that's going to come from. Alright, so that I just found the area of a triangle in terms of sides now, so now I can use that. I have all the same variables, so now we're going to go to trying to figure out the side. The side in this case is going to be equal to s, which is going to be equal to the sine of x. Right, so this distance right here, that distance right here would be the sine. So if I were just getting the area of one triangle, this would be the side of it. And because it's an equilateral triangle, that's actually all the sides. All right, all the sides are equal to sine x. So that would give me the distance, the base of that triangle. So therefore, 3, to figure out the cross section, right, I'm going to go between 0 and pi, and this is the work you have to do. Obviously, if you remember the sine function, you'll be able to know that. Okay? Or, sine of 0 is 0, sine of pi is 0. So this would be, let's see, remember this square root of 3 over 4 came from here. Now instead of psi square, instead of this, I'm going to have that right there. Right, so I'm going to have sine of x squared dx. Now if I integrate that with my calculator, I get 0.680 units cubed. And yeah, make sure you put your units on there. Right, as you can see that, hopefully it's not too bad. The hardest part for this is the picturing of it. Alright, now the back, I'm going to go through it fairly fast. Alright, so if you have any questions, make sure and ask. Like tomorrow, because obviously I won't be able to hear you. Or will I? I'm just kidding. Alright, so alright, next part. Alright, please read the problem here. You have this area right here. Now this is going to be different, slightly. See, find blah blah blah, x is equal to 0. Alright, so this is the area that's being bounded. Alright, this is the area. Perpendicular to the x-axis. Okay, so yeah, this is still going to be my thickness, if you will, delta x. And notice that I want to use, let's see, so we have different stuff here, alright? Notice that they give us this equation, which I have to get in terms of y, and if I do, I get y is equal, or y squared is equal to 4 minus x. So y is equal to plus or minus the square root of 4 minus x. Alright, so to do semicircles, the area of a semicircle is 1/2 pi r squared. Remember, pi r squared is the area of a circle, so a half of that would be 1/2 pi r squared. Alright, step number 2 is I need to figure out what the radius is in this case. Alright, the radius in this case would be, the radius of the semicircle would be just this little piece right here, if you can see it. And that right there, that would be equal to, you would have the bottom minus the top. In this case, the top minus the bottom. The top is the square root of 4 minus x, and the bottom is 0 because that would be the y-axis here. Sorry, the x-axis. So that would be it for that. And then finally, I would have to find the volume of the cross section. So I'm going to go between 0 and 4. Now again, it's 0 because the x is 0, and then 4 is just because that's where he does this right here. That would be 4 right there. Alright, so we have 1/2 pi, and instead of the radius, I'm going to plug this in. So I have 4 minus x squared dx. And when you plug that in your calculator, you get 12.566. Alright, and the next one is the same idea, but we have, notice that the one rectangle is with the height of half the base. Alright, so the first thing we do is write the formula for a rectangle. So we have base times height. On number 2, you get the base is equal to 2 times 4 minus x. Now, if you can see that, think about it. The base, that would be the whole base right here. If this little part right here is the square root of 4 minus x, and this is the negative square root of 4 minus x, you would add those two together and you get this. Okay? And therefore, because the height is half the base, so half of this number, I would have 1/2 the base, which would be equal to 4 minus x. Alright, so number 3, to find the volume of the cross section, would be equal to between 0 and 4 again. And notice that the base is this number, and the height is this number. So I have 2 square root of 4 minus x, square root of 4 minus x dx, and when you put that on your calculator, that's equal to 16. Okay, finally, that last one, please use the knowledge that I gave you from before. So 1/2 base times height, and if you remember, this ends up being the square root of 3/4 s squared. All right, that's what you have. Now notice that what makes this one different, this is the cross section you're looking at. This would be dy. So you actually have you have to have everything in terms of y. Okay, so on number 2, all right, to find this side right here, you actually have to do the side is equal to the right curve minus the left curve. And the bell's about to ring, so if you hear a lot of commotion, that's me trying to finish this video. All right, so this would be s is equal to the right curve is x is equal to 1. And the left curve would be this curve right here, which is x cubed. Okay? Now if you go ahead and find the volume of the cross section, that's going to be equal to the integral between, hold on, let me see that. The integral between 0 and 1. Notice that again, I'm going to find many areas of many different triangles, and that's what the integral does for me. And real quick, this right here came from me solving, this right here came from, I should have written this as, nope. Notice that right there, x cubed, would be equal to, x is equal to the y to the 1/3 power. Right, and if you do that, you get the answer. Sorry, you hear all this noise because everybody's coming in for class now.